So we have drawn this plan. I add the actual dimensions around the building. I'm gonna draw the sections. One section coming through the entry area because it's based on my brief, and also good to actually figure out the stairs and windows. So I'm looking this way. Okay, so this is the sections. So I'm gonna draw, just mark them. So this will be the section marks for me. So I'm just draw first. So that will be my sections. So that means I'm coming through this side. So indicate these sections. So one more tracing paper. Obviously, when you done your floor plan, I think we'll use based on floor plan. So all the dimensions all set out, so it will be much quicker. So I'm setting out. Total building height in our brief. Total height, the rooftop is 4050 here. Okay, it's from the ground. So total height is 4050. So what I do, obviously, the dimension is the same. Just then I will have a little one of the white papers for useful. I'll just prepare white paper. So let's have a look here. So we got the dimensions, all the annotation will go under here. Okay, will be only discussed. Initially, I will just copy the actual overall dimension first. Okay. But you can't see at the moment, but you'll see it later. So whatever necessary dimensions, I just copy them. Okay. So this is a bathroom window. Somewhere there, and then shower. Okay, so another piece of paper. So I'll just quickly mark up first. Okay, so overall building height is 4050, so I just want to make sure within the paper space 4050. So it's quite high, so I have to adjust it high. I think this is probably better. A little bit more. Nice and center. Okay, that's good. Okay, 4050. So this is the one. Yeah? 600 mil high for floor. Okay, so I'll just mark together. I'll use pencil first. Okay, then we'll set out. So what I did, this is our ground level. I did, and that is the total building height, 4050. I draw. Okay, this is our floor level. Floor level. Ceiling is 2.7. Based on our bridge. Okay, so it will be somewhere there. Okay, so this is a ceiling. So now we actually they're showing all the height. So this is stay outside, but we'll draw a bit later. So I'll focus on inside how you set up your drawings. Okay. So hopefully you can see it. Yes. This is the external. And then this will be a stair will be happen. So this is sort of ideas, and also this is a wall, internal wall. Yeah, maybe we'll go all the way out, but we'll draw in. So basically it's setting up like this. Okay, and also we have steps. So I need to know where. So let's go back to our drawing. Okay, so I add this information. So I add the steps here. So actually this area is a bit higher than this area because of the toilet. Let me go back to my original drawing. So what I did actually, I think in this dimension, a bit of calculation before, about 420 mil higher than actually floor level, based on my sketches. So I add 420. It's your design could be different. If someone has steps, obviously add on to it, but if we don't have steps, this is my design as steps, yeah? So that's what I'm adding here. 420. So then I will just figure out the steps. Let me draw steps. One step in front. Okay. So that will be steps. Okay. So that's where the step will go. Okay. So that is actually high, okay? And then steps will be happening like this. And this is your floor finish level outside. I personally tried to make it a bit outside, a bit about 50 mil low. because just in case all the waters, so if you want to make it seamless, then you can, just flow through inside, but probably a bit more outside would be less, about 15 mil. I think it's a good practice, I guess. If we all the dust, dirty comes in, so there is actually some area it doesn't get it in. Okay. So that is your internal steps here. Okay. So now we can see a overall set out here. Okay. So then in our structural drawing, when you look at this structural drawing over here, there's actually basic the bone of this building is already there. So we just try to apply this information on this section. So we already figured out the column location and also beam, and also in the roof beams, and all good. And then what you call it, the columns, we all set out previously. Okay, so we just try to repeat actually this information on these sections. Okay, so let's have a look here. Okay. So previously I set out all the column locations. Okay, so over here. So what I do, I need to add the information about column and then exact location of floor beams. So when you look at this handout, because I'm cutting through a section like this, so I need to add this information, okay, called GB2. Okay, and this is all the floor joist, which is the same as timber structure, timber construction. So if I know GB2, I already work it out all the size. GB2 200 PFC. Okay, so then I apply this information over there. But before actually applying this information, we need to know what is the finishes on your bath house, floor finishes. So if you imagine your tile, if you're adding tiles or something else, and then you need to know what is the thickness and what is underlays. So when you look at this, the structure floor plan, we need to add so 22 mil structural board. It's like a chipboard. So on the top of the what do you call it? Floor joist. Okay, so let's look at what it looks like. So this is the finished floor levels. Okay, so I need to add the information before reaching where the location of all this beam. Okay, so what I do. Let's look at this area. Okay, so one of the area, what will happen? So let's imagine this is the floor finishes. Okay, we have a tile. Okay, tile is about 6 mil. Okay, some tiles a bit thicker, but we allow for about 10 mil. Okay, 10 mil for tile, 10 or 12 including glue. Okay, about 12 mil. Let's say. And then on the top of the, just below, the waterproofing membrane. Obviously there is no thickness we allow for that one. In this case we allow for about 20 mil is probably better. 12 mil is difficult to draw, but if we actually adjust all the levels, I think we just allow about 20 mil for tiles and other finishes. Okay. And then just below, waterproofing membrane. Okay. Then below, they are using a compressed cement sheet. I'll just draw about 6 mil. I think it's 6 mil. Okay. Compressed. There you go. 6 mil under. Okay. So underneath, and they put actually another liquid waterproofing under again. Okay. Then below, the structural board, the 22 mil structural board. So this is a 22 mil structural board. So then underneath the beam, what is it? The PFC beam. When we get this brief, so we are cutting through like this, isn't it? The GB2 size. I worked it out the size a GB2 is I think a PFC. So the channel shape is a 75 by 200. I just worked it out too. So underneath, for instance, it looks like that. Yeah? Okay, so this is a PFC, 75 by 200. Okay, so basically this is the edge of the wall, but just adding up. So let's think about what is the total thickness. Yeah? So 12, okay, we allowed for about 20, wasn't it? Yeah? 20, about 6 mil. And then another 22. Okay. So what is together? You don't need to. So 42, 48. Okay. So this is actually 48 millimeters. Okay, so that total, if you glue all together, I think around 50 mil, total together. Okay, so slight judgment. But when you're drawing, we draw 50, so total thickness is 48. But if someone want to have a timber on the top, it's a completely different story. Okay, so timber thickness about 22 mil thickness with underlays and glue together. So it could be a much thicker than that. If someone uses steel, it's different thickness. So you need to know what the really the finish is here. Okay, and this is the beam. Okay, so this is a GB1. So in between there is a floor joist is there. So we need to cut through. So floor joist size C channel 200. Okay, so C channel 200. So we already got size here too. Okay, so a 200, 75, almost similar size of the C channels. Yeah? So 5 similar things. It's like that. So this is the joist. So this is called FJ1. So you probably look at your engineering all the size members, then we applied. Yeah? So that's what the thickness we allow for. Okay, so now we have this information. Then what I do, I will apply here. Okay, but in my case it's slightly different for you guys because my one, I have to raise the. Okay, so I allow for 50 mil, 50 mil there, then I can position the way the beam location is. Okay, so let's check it. So that is a rough thickness. Okay, so that's what happened over there. So we already know all the wall thickness. Okay, based on street design. So based on this information, from the column to the actual finishes, we allow for I think 80 mil before. Okay, so what do you do? I probably offset about 80 mil from outside. So also we have information already there below, so we can copy them too. But so this is the what will happen. Okay, it's a timber stud and good location all there. But okay, so let's go back. So I know this is thickness of the wall. So I can position the beam size. Okay, so GB1, so 75 by 200. Okay, 200. I'll just draw the red color. So now you can see the location of the beam. Okay, so I will draw here. But this could be slightly different because I raised up. Okay, so I might actually the copy over there. Maybe this floor itself just raised up. Okay, so I can do it that way too. So I'll just copy them. It's better actually all one same level. Just for red color for you. So I know roughly actually what happened. Then we need to sort it out this area as well. Okay, so I'll come back. Let's think about what will happen on the top. So we sorted out the floor beam, and also we need to work it out on the roof beams. Okay, so when you look at this as a frame drawings, so this is all the the ground beams. Okay, ground floor beams, and then this is probably all the ceiling and roof beams there. So we're cutting through like this. Okay, so I already drawn this one. Yeah. So now we actually go back. So I need to find out. So this is the PB1. So I need to position on a drawing. So, but I don't know exactly where the location is. So I have to actually find out. the locations. Okay, so let's have a look. So PB1 size, so this is about 250 UB. Okay, so I already worked it out, 250 UB. Just like this is the shape of UB. If it's 250, that means about 248 by 124. Okay, so that is a size. Yeah? Okay, so I have to actually locate somewhere around here. Okay, but this is our ceiling finish level. Okay, so obviously whether we can exactly this position 2.7, but I don't think so. But we have to actually make it slightly higher, so to be able to ceiling finishes and can go any wires, you know, all other services that it can go through. So I might slightly make it higher, so then we'll work it out what it looks like. Okay. So let's have a look in this drawing. So this is ceiling finishes. Okay, this is wall. We already know thickness. We worked it out before. So this is we allowed about 238 millimeters total. Okay, so this is ceiling. So what I do, when you do ceiling, ceiling has a plasterboard, or maybe I talk to a mirror. Okay, so I'll up about 10 or 15 mil because the mirror is on the top. For my building, maybe your building is different. Yeah, if we plasterboard, let's say 10 because mirror I add. Yeah, so that is about 2,700. So that's our level we have to go for. Okay. And also for the ceiling, we had to be a bit of researches before. Ceiling material and the ceiling structure.